Okay, in section 3.4, we're going to talk about quadratic models. The best way to handle this section was just to do some problems in the book, I thought. So let's get right to it on page 166, problem 4. Maximizing revenue, the price P in dollars and the quantity X sold of a certain product obey the demand equation P equals negative 1/3 X plus 100. Part A, find a model that expresses the revenue R as a function of X. The revenue is X times P of X. Okay, so I would just simply multiply P of X times X to get R of X. Part B, what is the domain of R? The domain of R would be so I set X equal to X times 1/3 X plus 100 equal to 0. X equals 0. Negative 1/3 X equals negative 100 means that X is equal to 300. So between 0 and 300 is the domain of the function. Problem C. What is the revenue if 100 units are sold? Okay, so R of 100 is let's see here, 100 times 100 minus 1/3 times 100 squared is 6,666.67 is the revenue. Okay. Part D, what quantity X maximizes the revenue and what is the maximum revenue? Okay, so we have to find the highest point on the function, and so in order to do that, B divided by negative 2A, so I want the opposite of B, divided by 2A. The opposite of 100 is negative 100 divided by 2A divided by negative 2/3. If I flip the denominator, negative 300 divided by negative 2 is 150. R of 150 is 750. So the items for the max revenue would be 150 items. And the max revenue that I can get is $7,500. Okay. Part E, what price should the company charge to maximize the revenue? Here's the price equation. P of 150. Negative 150 divided by 3 is negative 50, plus 50 is 50. Okay. Problem 10. Problem 10. Okay. A farmer with 2,000 meters of fencing wants to enclose a rectangular plot that borders on a straight highway. If the farmer does not fence along the side of the highway, what is the largest area that can be enclosed? Okay, so we've got a rectangle. I've got X and Y. Not gonna fence along the highway. I've got just these three sides here. 2x plus y equals 2,000. Y is equal to negative 2x plus 2,000. So I want to maximize the area. The area of a rectangle is length times width. X times y is x times y. Negative 2x plus 2,000 times x is negative 2x squared plus 2,000x. Okay, so the vertex, maximize is the key word. The vertex, I want negative b divided by 2a. Negative 2,000 divided by negative 4 is 500. A of 500 gives me 500,000. So the maximum area that can be enclosed here is 500,000 meters squared. Okay. Problem 12. We're analyzing the motion of a projectile. A projectile is fired at an inclination of 45 degrees to the horizontal with a muzzle velocity of 100 feet per second. The height h of the projectile is modeled by the function h of x equals negative 32x squared divided by 100 squared plus x, where x is the horizontal distance of the projectile from the firing point. Part A, at what horizontal distance from the firing point is the height of the projectile a maximum? And then part B, find the maximum height of the projectile. Okay. Well, that's just an exercise in finding the vertex. So 100 squared is 10,000. And I've got the opposite of B divided by 2A. 2A means I've got 10,000 divided by 64. Okay, since the opposite of B is negative 1 divided by 2A, negative 64 over 10,000. And then h of 10,000 over 64 gives me the height of the projectile. So the distance to the max height is 156.25 feet. And the max height that we would get is 78.125 feet. Okay. Part C, at what horizontal distance from the firing point will the projectile strike the ground? Okay, well, the firing point is, you set that equal to 0 and solve this equation for x. X is in common to both those terms, so I can factor out x. And if I subtract 1 and multiply by 10,000 over negative 32, then x is equal to 10,000 over 32, which is 312.5. Since the distance cannot be 0, the projectile is going to land at 312.5 feet from where it was fired. Okay, and that's it. That's what the question is asking. At what horizontal distance from the firing point will the projectile strike the ground? Okay. Let's see here. Part D and Part E. Oops. Use the graphing utility, graph the function h on the interval 0 to 350, and part E, use the graphing utility to verify the results in parts B and C. Okay, so we graph the function, and let's see here. So graph. There's our picture, and second trace, maximum. Okay. Okay, so there's 125.25, 78.125. Okay, the 0. Okay. 312.5. Okay. So let's see here, part F. Part F. When the height of the projectile is 50 feet above the ground, how far has it traveled horizontally? Okay, so I would set the height equal to 50 feet and solve the equation when this is equal to 50. Subtract 50 from both sides, and okay, so I want the opposite of b, which is -1 plus or minus the square root of 1 minus 4 times a. A is -32 divided by 10,000 times c is -50 divided by 2a, -64 over 10,000. And that is equal to -1 plus or minus the square root of 0.36 divided by -0.0064. Okay, and that's exact, by the way. Square root of 0.36 is 0.6, so -1 plus or minus 0.6 divided by -0.0064. Okay, I get 62.5 as one of these values, and then 250 as the second value. So I've drawn a graph here, real quick. Here's 50 feet above the ground is where I'm estimating, and at 62.5 feet and at 250 feet. I'm going to cross that marker. Once on the way up, it's going to continue to go up until 156.25 seconds have gone by, and then it's going to land on the ground. Okay. Problem 14 is an architecture problem. A parabolic arch has a span of 120 feet and a maximum height of 25 feet. Choose a suitable rectangular coordinate axis and find the equation of the parabola. Then calculate the height of the arch at points 10 feet, 20 feet, and 40 feet from the center. Okay, so I've drawn a graph of the arch. It's got a span of 120 feet and a height of 25 feet. The function that we're going to want here, f of x, is equal to ax squared plus c. Okay, think about transformations. Okay, a is going to be some negative number, and c is going to be how high up the axis this is. So c is 25. We get that immediately. And f of x is equal to ax squared plus 25. F of 60 equals 0. Means that 0 is equal to a times 60 squared plus 25. Okay, so 60 squared is 3,600. Negative 25 divided by 3,600 is the a value. Okay, and here's the function that we're going to want. F of 10 is 24.3 feet, approximately. F of 20 is 22.2 feet, and f of 40 is 13.9 feet. And of course, as I would go out to 60, the height is going to decrease. Okay. Problem 16. You got a Norman window has the shape of a rectangular surmounted by a semicircle of diameter equal to the width of the rectangle. See the picture. If the perimeter of the rectangle is 20 feet, what dimensions will emit the most light? Maximize the area. Hint, the circumference of a circle is 2 pi r. The area of a circle is pi r squared. R is the radius of the circle. Okay, so here's a picture of a Norman window. I got that drawn. The area is R is the area of the rectangle is W times L, and the area of the circle is pi times 1/2 pi r squared. Okay, so I've got the circle, the circumference 2 pi r, and the circumference of half the circle is pi times r. Circumference of or area of a circle is pi times radius squared. Area of half the circle is 1/2 pi times the radius squared. The perimeter of the rectangle is 2L. Here's 2L plus R plus another R. Okay. This is just the perimeter of the rectangle, R and R. 2L plus 2R is 2L plus W. Okay, and the area of the rectangle, L times 2R, or L times W. Okay, the Norman window perimeter is the area of the half circle plus the area of the rectangle. Okay, or the perimeter. 2R plus 2L, and then plus half the circle is 20 R plus let's see here, 20 the circumference of half the circle is 2 pi times the radius. Okay, pi times the radius. The circumference of this the perimeter of the rectangle is 20. Okay, so 20 is equal to pi times the radius plus 2R plus 2L. If I solve this for L, 20 minus pi times R minus 2R divided by 2 is the length of the rectangle, and the Norman area, the Norman window area, then is where I take the area of the rectangular part plus the area of the semicircular part. The area of half the circle is 1/2 pi r squared plus the area of the rectangular part would be L, which is this guy right here, times 2R. 2R is the same as W. Okay? So I got, when I simplify this, negative 1/2 pi minus 2 times r squared plus 20r. Okay? And that's what I've got to find the vertex for. The vertex, opposite of B divided by 2a, negative 20 divided by 2a, negative pi minus 4, and then a of negative 20 divided by negative pi minus 4, negative over negative is positive. 20 divided by pi plus 4 is 2.8, approximately. And then a of 2.8 is 28. Okay, so they're asking for the maximum dimensions of the window. In other words, we need to maximize the width and maximize the length. The width is 2r. R is 2.8 times 2 is 5.6 feet. Okay, and then the length, 20 minus 2r minus pi r divided by 2, if I let r be 2.8, then the length is approximately 2.8 feet. Okay, so the Norman window should look something like this. then in order to have the maximum amount of light go in. Okay. The homework in this section is on page 166. Have a look at these problems for me when you get a chance.